So in this video, we're going to show frequency offset measurements with a power sensor. I have a U2022XA hooked up to my FieldFox, and I am in the regular power meter power sensor mode. So then I go into frequency and I switch it to swept, and then I want to enter my start-stop frequencies, so I like to see my display in start-stop. Then I go into offset calculator, and my input frequency is 28 gig to 40 gig. And I don't have a real DUT here, but let's just kind of pretend we do. And a stop of 6 to 18 gigahertz. Then we say calculate offset, and it calculates an offset of 22 gigahertz. This is a down converter, 22 gigahertz offset. The source power is minus 15 dB, and that's fine. You can try to go higher. I'm not quite sure exactly what we can deliver, but let's leave it at minus 15. So then we'll come ahead and we say measure. Oh, and I'm going to change a number of points just for the sake of this example to 21, because power sensors take a long time, so it goes a bit faster. And here is, by the way, where you would want to set the power level. You know, if we could try to go a little bit higher. At some point we're going to get an unleveled error. Okay, it can deliver minus 10, but I think if I go to 5, for example, let's see, will I get unleveled? It still can do it. Let's try. Okay, so we go to measure, source power measure. And here it says connect your power sensor directly to where your source would go into your DUT. This is your RF input. And this is actually the frequencies. It calibrates the RF frequencies in the source. There's no calibration on the receiver side. It normalizes and says, what is my input power? For your conversion loss, you have your B over R. So this is the R that it's measuring. So we'll go ahead and say measure. And you can see the measurement was done from 28 gigahertz to 40 gigahertz, which is the input. Then I say source data to memory, and I say done. Now if I can look at the source power, or I can look at the gain. And the gain is showing 0 because I have no loss. I don't have a converter here to actually see this measurement. But the output is measured in this 6 to 18 gigahertz range. And I just want to show you this diagram. The assumption is that the sensor is going to the DUT output. If you have a cable, if you have something on the output that is between the DUT and where your sensor goes, that's not really getting corrected for. I think that's the question of, is there any calibration on the receiver frequencies? And there isn't, because the assumption is that the power sensor is connected directly to the DUT output. And so the measurements are accurate. So that's in your B over R, it's this R measurement at the receive frequency. And we've done this measurement I just did this a few weeks ago with a converter, for a satellite converter, and the numbers matched very well with other systems. So I'm confident that the measurement is accurate and it works. I also want to point out that it's important to pay attention to harmonics. This is a broadband sensor. FieldFox source does have harmonics and subharmonics, so you want to look at your input frequencies on the spectrum analyzer. You want to look at your output frequencies to be aware of what is your broadband power sensor measuring. And that's it.